You shave, the hair is gone. Clean, smooth, done. And then almost like it never happened, it comes back. Thicker looking, darker, stubborn. And you've probably wondered at some point, why does your body keep doing this? Why does it grow hair in the first place? And why won't it just stop? The answer reaches all the way down into your biology, your evolutionary past, and one of the most persistent myths in all of human science. Let's start at the root. Literally, because to understand why hair grows back, you need to understand where hair actually comes from. Most people assume hair is dead tissue, and that's partly true. The strand you see poking out of your skin? Dead. But buried beneath the surface, inside a tiny tunnel called a follicle, there's a cluster of living cells that are very much alive. These cells divide constantly, pushing new material upward. The strand is the byproduct. The factory is underground. And here's the key thing about shaving. It never touches that factory. A razor only cuts the shaft, the dead part sticking out above the skin. The follicle, nestled safely beneath the surface, doesn't even know it happened. It just keeps producing. It's a bit like mowing a lawn and expecting the grass to give up. The roots are untouched. The growth continues. But here's where it gets interesting, because that's only the mechanical explanation. The deeper question is why the body is so committed to making hair at all. To answer that, we have to go back, way back. Because hair is ancient. Our ancestors, millions of years ago, were covered in it. Full body fur, like the other great apes. And for them, it wasn't cosmetic. It was survival. Hair trapped air close to the skin, insulating the body from cold. It protected against sun exposure. It even played a role in communication. Think of how animals raise their fur when threatened. Hair was a full-time biological tool, and evolution doesn't throw away tools easily. Humans, over hundreds of thousands of years, lost most of that body fur, but most is not all. We still have follicles covering nearly every inch of skin, about 5 million of them across the whole body. Some produce thick, visible hair. Others produce the fine, barely visible vellus hair that covers your arms and cheeks. But they're all there, quietly doing their job. The body kept the infrastructure, even as it scaled down production. And the reasons it kept certain patches, eyebrows, underarms, scalp, are fascinating. Take eyebrows. They seem almost decorative now, but they solve a specific engineering problem, keeping sweat and rain out of your eyes. That arch isn't random. It redirects liquid to the sides of your face. Studies of people born without eyebrows show real difficulty with visual clarity during physical activity. The body kept eyebrows because they work. And your eyelashes? They're basically biological air filters. They catch dust and trigger the blink reflex before particles can reach the eye. Every patch of hair your body maintains has a reason, or once had one. But what about underarm hair, or hair on legs? Some researchers believe underarm and pubic hair once helped reduce friction during movement. Skin on skin creates chafing, and hair acts as a buffer. There's also evidence it plays a role in dispersing pheromones, chemical signals the body still produces, even if we're less consciously aware of them than other animals. Your body hasn't fully let go of its chemical communication system. The hair helps broadcast it. Strange thought, isn't it? That your grooming habits are working against systems that have been running for millions of years. Now, here's the myth we need to tackle, because it's one of the most widespread misconceptions in everyday biology. You've probably heard it. Maybe you believe it right now. The idea that shaving makes hair grow back thicker, darker, or faster. It feels true. You shave and what comes back seems coarser, more noticeable. But here's the thing. It's completely false. And the science behind why it feels true is genuinely fascinating. When hair grows naturally, the tip is tapered. It comes to a fine point. That's why it feels soft and looks lighter. But when you shave, you cut straight across the shaft at its widest point, leaving a blunt, flat edge. As that blunt hair grows back out, it presses against your skin and fingers differently. It feels stubbly, rough, more noticeable. But the hair itself is exactly the same thickness. You haven't changed the hair at all. You've just changed where you're encountering it in its growth cycle. Your perception is the thing that changed. Scientists have actually tested this. Studies going back decades, including a controlled study published in a dermatology journal in the 1970s, that's been replicated since, found no measurable difference in the width, color, or growth rate of hair before and after shaving. The follicle simply doesn't receive any signal from the razor. It has no nerve connection to the surface. It doesn't know. It just keeps doing exactly what it was doing before you ever picked up a blade. But now let's go deeper. Because hair growth isn't constant. It's cyclical. And the mechanism behind that cycle is one of the more elegant pieces of biological engineering in the human body. Every single follicle on your body runs through 3 distinct phases, independently, on its own schedule. They're not synchronized. Right now, different hairs on your head are at completely different stages of their life cycle. And that's intentional. Phase 1 is anagen, the active growth phase. For scalp hair, this can last 2 to 7 years. That's why some people can grow their hair to their waist, and others can't get past their shoulders. The length of your anagen phase is largely genetic. Phase 2 is catagen, a short transition phase lasting a few weeks, where the follicle shrinks and the hair detaches from its blood supply. Phase 3 is telogen, a resting phase lasting a few months, before the old hair sheds and a new one begins growing. You lose between 50 and 100 scalp hairs per day just through this normal cycle. And here's something most people never think about. The reason your scalp hair can grow so long while your arm hair stays short isn't the growth rate. Both grow at roughly the same pace, about half an inch per month. The difference is entirely in the duration of the anagen phase. Your arm hair has a very short active growth period, maybe a few months, before it cycles out. That's why it has a natural length limit. It reaches a certain point and stops, not because it ran out of energy. This also explains why some body hair seems to grow back almost immediately after shaving, because those follicles were already in an active anagen phase. They weren't waiting for a signal from the razor. They were already mid-production when the blade came through. All shaving did was trim what was already on its way, which raises an uncomfortable question. Is shaving in any biological sense even doing anything at all? Or are we just perpetually interrupting a process that was never going to stop? That's not just philosophical. It has real implications. Because there are people who want the hair to actually stop, not just be cut. And the technologies designed to do that reveal something even more interesting about what hair follicles really are. Laser hair removal, for example, works by targeting the pigment in the follicle with concentrated light, generating heat that damages the follicular cells. Electrolysis goes further. It sends an electrical current directly into each follicle to destroy it permanently. Both techniques are attacking the factory, not the product. And even then, even with laser treatments, it often takes multiple sessions to fully deactivate a follicle. Because follicles in the telogen resting phase aren't actively producing pigment, which means the laser has less to target. You have to catch them at the right moment in their cycle. The follicle is remarkably resilient. It's been refined over millions of years of evolution to be hard to stop. Your body treats hair production as a non-negotiable. Here's the mid-video twist that reframes everything. We talk about shaving as if it's a battle between you and your body. You trying to remove hair, your body stubbornly regrowing it. But that framing has it completely backwards. Your body isn't responding to shaving at all. It's indifferent to it. The hair would be growing right now, even if you'd never shaved in your life. You're not fighting your biology. You're just running alongside it, trimming as it goes, and interpreting that as resistance. The body isn't pushing back. It's just moving forward. This becomes even more striking when you look at what can actually disrupt hair growth, because it's not a razor. What genuinely slows or stops hair production is systemic. Severe nutritional deficiency, hormonal shifts, chemotherapy drugs that target rapidly dividing cells, which follicular cells are, extreme physical stress like surgery or illness. These things can trigger a condition called telogen effluvium, where large numbers of follicles simultaneously enter the resting phase, causing noticeable hair shedding weeks or months later. That delay is important. Telogen effluvium often appears months after the stressful event, which is why people sometimes lose hair after recovering from a serious illness or after the intense stress of a major life event. The body's response is delayed. It registered the threat, but the hair loss shows up on a lag. It's the follicle's way of saying, the body deprioritized non-essential production during the crisis. Hair is never the first priority, but the moment things stabilize, the system restarts. And this tells us something important about what hair actually costs the body. Growing hair isn't free. It requires protein, iron, zinc, biotin, and a steady blood supply to each follicle. The body is constantly investing resources in this process. When those resources are diverted, during illness, famine, extreme stress, hair production is one of the first things scaled back. It's an energy expenditure that the body considers worth making under normal conditions, but will sacrifice during genuine crisis. That's not a trivial calculation. Which brings us to hormones, because they're arguably the most powerful regulators of hair growth on the body. Androgens, particularly testosterone and its derivative DHT, have a paradoxical effect. They stimulate hair growth on the face, body, and underarms, while simultaneously, in people genetically predisposed, miniaturizing follicles on the scalp, which leads to male and female pattern baldness. The same hormone that drives beard growth can, over years, cause scalp hair follicles to shrink, produce thinner strands, and eventually go dormant. This is why hair loss treatments often target hormones. Finasteride, one of the most studied hair loss medications, works by blocking the conversion of testosterone to DHT. It doesn't make follicles grow, it removes the hormonal pressure that was shrinking them. And in many cases, once that pressure is lifted, follicles that hadn't fully died begin producing again. The factory was never destroyed, it was just suppressed. This distinction between damaged follicles and suppressed ones is at the heart of modern hair research. Scientists are actively working on ways to reactivate dormant follicles, not just slow the hormonal damage but reverse it. Research into stem cells within the follicle's bulge region has opened up new possibilities. These stem cells are responsible for regenerating the follicle with each new growth cycle, and researchers believe that stimulating or replenishing them could restart production in follicles that have gone quiet. We're not there yet at scale, but the biological machinery may be more repairable than we once thought. And here's the detail that genuinely surprised me when I first encountered it. You're born with every hair follicle you will ever have. The body forms them all during fetal development. No new follicles are created after birth. The number you're born with is the number you keep for life. When follicles are destroyed by scarring, severe burns, certain skin conditions, that hair is gone permanently. The body can maintain what it has, suppress what it has, even reactivate what it has, but it cannot build new follicles from scratch. That window closes before you're even born. So let's bring it all together, because this is actually a beautiful system when you see it clearly. Your hair grows back after shaving because the razor never reaches the follicle. The follicle is alive, cycling through phases, powered by nutrients and hormones, doing a job your evolutionary ancestors absolutely needed it to do. Shaving is cosmetic interference with a biological process that predates modern humans by millions of years. The stubbly regrowth that feels coarser? A trick of geometry. The follicle is unchanged. It didn't react to you. There's something quietly profound in that. Your body is running ancient code, instructions for hair growth written into your DNA millions of years ago, tested and refined across countless generations, so robust that a razor at the surface doesn't even register as an event worth responding to. You are, in a very real sense, still the animal your ancestors were, just with better tools and a different relationship to fur. And the next time you feel that stubble coming in, maybe instead of frustration, there's a small flicker of awe. That's not your body fighting you. That's your body just being what it has always been. And that leaves us with one final question worth sitting with. If our bodies still grow hair almost everywhere, still maintain 5 million follicles, still run these ancient hormonal programs, what else are we carrying forward from a version of ourselves we've never met? What other evolutionary software is running quietly in the background, shaping the way you feel, the way you respond, the way your body makes decisions you never consciously authorized? Hair is the visible part, But the code goes so much deeper than that.